Okay. So I start by saying let Pn be the given mathematical statement. 1 by 3 into 6 plus 1 by 6 into 9 plus 1 by 9 into 12 and so on up till 1 by 3n into 3n plus 3 is equal to n divided by 9 times n plus 1. This is what you have to show. This let Pn be the given mathematical statement. Right? Okay. So for n is equal to 1. Okay. What is the left hand side? Only the first term, right? 1 by 3 into 6, which is equal to 1 by 18. What is the right hand side? 1 by 9 into 1 plus 1. That is 1 by 9 into 2, which is equal to 1 by 18. Right? So left hand side is equal to right hand side. Therefore, what can we say? Thus, Pn is true for n is equal to 1. That is, we say P1 is true. Right? So we have from the statement, if you see the first part of the statement, we have verified. Okay, that is P1 is true. Now we are going to verify the second part. That is Pm plus 1 is true whenever Pm is assumed to be true. Okay, so let us assume the statement Pm. So let us assume the statement Pm. What is the statement? 1 by 3 into 6 plus 1 by 6 into 9 plus 1 by 9 into 12 till 1 by 3m into 3m plus 3 is equal to m by 9 times m plus 1, where m is a natural number. Okay. Now, assuming Pm, we need to show which statement is true. We shall now show that Pm plus 1 is true whenever Pm is assumed to be true. What is where m is a natural number. Okay. So let's write Pm plus 1. 1 by 3 into 6 plus 1 by 6 into 9 plus 1 by 9 into 12. Now you may wonder why I'm doing so much of writing. This is actually to show you which statement I am assuming and which statement I need to prove. Okay. So it's for you, it is better if you do so much of writing. Otherwise, you will get confused which one to assume, which one to prove. Okay. So you have Pm plus 1 as this is the mth term, right? What is the m plus 1th term? There's an extra term in Pm plus 1. Thrice m plus 1 into thrice m plus 1 plus 3. Right? Which is equal to m plus 1 divided by 9 times m plus 1 plus 1. This is what you have to prove, right? So you have to prove this statement, pm plus 1, assuming this to be true. Okay. So what we do is whenever we assume a statement, we start with this statement. Okay. So we start with pm. So we have 1 by 3 into 6 plus 1 by 6 into 9 plus 1 by 9 into 12 and so on till 1 by 3m into 3m plus 3 is equal to m by 9 times m plus 1. So what should be the next step? If you see, it's because we have to prove pm plus 1, and in pm plus 1, from here till here you have, what is the only term that you don't have in pm? This one. So what we do, in order to convert pm to pm plus 1, we add this term to both sides, right? So adding 1 by thrice m plus 1 into thrice m plus 1 plus 3 to both sides. We get 1 by 3 into 6 plus 1 by 6 into 9 plus 1 by 9 into 12 up till 1 by 3m into 3m plus 3 plus 1 by thrice m plus 1 thrice m plus 1 plus 3. This is the term that we are adding to both sides, right? Is equal to m by 9 times m plus 1 plus 1 by thrice m plus 1 into thrice m plus 1 plus 3, right? This is the term that we have added to both sides. Okay. Now what do we have to show here? That you have to show that the sum of these two must be equal to this, right? Because assuming pm, we have to prove pm plus 1, isn't it? So you have to show that these two is nothing but this, because you have already got the left hand side, right? By adding. So you have already accommodated this term, right? By adding this to both sides. Okay. So how to show? See, we only need to work with the right hand side, because left hand side we have already made equal. So if you now see, you have m by 9 times m plus 1. You write this as it is, plus 1 by, now from here if you see, this is a 3, this is a 3, you can take this out, right? So I get thrice m plus 1, and if you take this out, you get thrice m plus 1 plus 1, right? So now this
Yes, sir.
becomes m by 9 times m plus 1 plus 1 by 9 times m plus 1 into m plus 2, right? Now from this, if you see, I can take out 1 by 9 times m plus 1 from both the terms. I can take out this common factor. If I am taking out this common factor, what am I left with? Here I am left with only an m plus 1 by m plus 2, right?
Yes, sir.
So I have 1 by 9 times m plus 1, and here now if you take the LCM, you will get m into m plus 2 plus 1 divided by m plus 2. Okay, so 1 by 9 times m plus 1, and if you now multiply this, you're going to get m square plus 2m plus 1 divided by m plus 2. So now here you're going to get 1 by 9 times m plus 1. Now what is m square plus 2m plus 1? It is nothing but m plus 1 whole square, right? By m plus 2. So now what you see here is that 1 m plus 1 will cancel and this 1 power will cancel from this. So what are you left with? M plus 1 by 9 times m plus 2. And what do you have to show? M 9 times m plus 1, right? So in the denominator you have, in the numerator it's okay, you're getting m plus 1. In the denominator m plus 2 can be written as m plus 1 plus 1, right? So you have shown the right hand side also to be equal, right? You have shown that the sum of these two is equal to this. So this shows that um, Pm plus 1 is true whenever Pm is assumed to be true. This shows that Pm plus 1 is true whenever Pm is assumed to be true for m belongs to n. Hence, by the principle of mathematical induction, Pn is true for every n belongs to n. Okay, that finishes the proof. Any question?
No, sir.
Let's proceed to the next question. C. Question number 1C. Okay. Look at this question. This is again a series question. 1 into 2 plus 2 into 3 plus 3 into 4 plus up till n into n plus 1. You have to prove that is equal to n into n plus 1 into n plus 2 by 3. So I say let Pn be the given mathematical statement. Let Pn 1 into 2 plus 2 into 3 plus 3 into 4 up till n into n plus 1 is equal to n into n plus 1 into n plus 2 divided by 3 be the given mathematical statement. For obviously n belongs to n, right? For n is equal to 1, what is the left hand side? 1 is the first term, right? 1 into 2, which is equal to 2. And the right hand side is 1 into 1 plus 1 into 1 plus 2, entire thing divided by 3. So you get this also equal to 2. Okay. So left hand side is equal to right hand side. So what can we say? Um, we can say that P1 is true, right? Thus, Pn is true for n equal to 1. That is P1 is true. Okay. So first part of the mathematical induction is has already been shown. Now the second part, that is, we need to show that Pm plus 1 is true whenever Pm is true. So let us now assume Pm 1 into 2 plus 2 into 3 plus 3 into 4 up till m into m plus 1 is equal to m plus 1, m plus 2 divided by 3, where m is a natural number. Okay, we shall show that Pm plus 1, and what is the statement Pm plus 1? 1 into 2, 2 into 3, 3 into 4. You have m into m plus 1, and you have an extra term. What is that extra term? M plus 1 into m plus 1 plus 1, right? Isn't it? And on the right hand side, you replace m by m plus 1. Okay, where m belongs to n. So, okay, so we have assumed Pm, so we'll start with Pm. So we have 1 into 2 plus 2 into 3, 3 into 4 up till m into m plus 1 is equal to m into m plus 1 into m plus 2 divided by 3. Now, in order to convert Pm to Pm plus 1, what we have to do, what is the extra term? This is the only extra term that is missing, right? If we add it to the left hand side, the left hand side will match, right? Only the right hand side we have to match. So, adding m plus 1 into m plus 1 plus 1 divided by okay, only this, nothing divided to both sides. We get 1 into 2 plus 2 into 3 plus 3 into 4 up till m into m plus 1 plus m plus 1 m plus 1 plus 1 is equal to, you have m into m plus 1 into m plus 2 divided by 3, and the term that we have added to both sides, which is m plus 1 m plus 1 plus 1, right? So now we need to match the right hand side. We need to show that the sum of these two terms must be equal to this, right? This is what we need to show. So let's proceed. Simplify first. You have m into m plus 1 into m plus 2 divided by 3 plus you have m plus 1 into m plus 2. Okay. Now if you see from these two, we can take which one's common? M plus 1 into m plus 2. M by 3 plus 1. is left, right? If you can see, m plus 1, m plus 2, and if you take LCM here, you're going to get m plus 3 by 3, right? So what are you getting here? 1/3 m plus 1, or let me write this as m plus 1 into m plus 2 into m plus 3 by 3, right? So now have we got this? Have we got this? This now can be written as m plus 1, m plus 1 plus 1 into m plus 1 plus 2, isn't it? This shows that Pm plus 1 is true whenever Pm is assumed to be true. For every n belongs to m belongs to n. Hence, by the principle of mathematical induction, Pn is true for every n belongs to n. Okay? No question?
No, sir.
I'll just start with the next one. I wonder whether I'll be able to finish it. If I'm able to finish it, fine. I'll just start with the next one. One D. Question here is half plus 1/4 plus 1/8 up till 1/2 to the power of n is equal to 1 minus 1/2 to the power of n. So I say let Pn be the given mathematical statement. Half plus 1/4 plus 1/8 till 1/2 to the power of n is equal to 1 minus 1/2 to the power of n. Be the given mathematical statement. For n belongs to n. Okay. For n is equal to 1. What is the left hand side? Only the first term, half. And what is the right hand side? 1 minus 1/2 to the power of 1, which is also equal to half, right? The left hand side is equal to right hand side. So thus, Pn is true for n is equal to 1. That is, P1 is true. Let us now assume Pm half plus 1/4 plus 1/8 up till 1/2 to the power of m is equal to 1 minus 1/2 to the power of m for m belongs to n. We shall now show that Pm plus 1 half plus 1/4 plus 1/8 1/2 to the power of m. And what is the extra term you have? Because it is Pm plus 1, you have 1 by 2 to the power of m plus 1 extra. Okay, and on the right hand side, what you have? 1 by 2 to the power of m plus 1. This is what you have to show. So assuming this, you have to show this. Okay, so let's start with our assumption. So we have half plus 1/4 plus 1/8 plus up till 1 by 2 to the power of m is equal to 1 minus 1 by 2 to the power of m. Now if you see, compare Pm and Pm plus 1, this is the only extra term that is lacking in Pm, right? So we add these two to both sides, this term to both sides. So adding 1 by 2 to the power of m plus 1 to both sides, right? We get half plus 1/4 plus 1/8 and plus up till 1 by 2 to the power of m, and this is the extra term that we have added, is equal to, you already had 1 minus 1 by 2 to the power of m, and the extra term that you added was 1 by 2 to the power of m plus 1. So now if you compare Pm and Pm plus 1, if we have to show this, so we have got this entire left hand side, right? What is only left to see? You have to show that this is equal to this, right? So let's see how to show. Is equal to 1 by 2 to the power of m plus, now this can be written as 1 by 2 to the power of m into 2, right? Is equal to 1 minus, now from these two, what can you take out common? 1 by 2 to the power of m. You can take common. If you take common, what are you left with? You're left with 1 here. And because you're taking minus sign and you're introducing a bracket, this sign will change to a minus sign. 1 minus half, right?
Yes, sir.
1 by 2 to the power of m, and 1 minus half is half, which is equal to 1 minus 1 by 2 to the power of m plus 1, right? 2 to the power of m into 2, isn't it? So have I shown this is equal to this? Have I shown? Yes. So this shows that Pm plus 1 is true whenever Pm is assumed to be true for m belongs to n. Hence, by the principle of mathematical induction, Pn is true for every n belongs to n. Right? That finishes the proof. I'll stop here.